Hi, in this video I'm going to show you how to use the PlantAI tool to generate plant counts and count the plant level data. But first, what is PlantAI tool and how does it work? So as the name implies, PlantAI tool uses AI technology, which means that rather than having some sort of custom algorithm behind the scenes customized for specific crops, the tool can learn from the examples that you as a user provides, and you can train it to identify and count almost any type of crop, and not even crop. You can even identify weeds. So you can adjust it to your specific situation. So let's have a look at two examples here and see the workflow and how the tool works. So in the first situation here, we have a cabbage field a few weeks after the planting, and as a vegetable grower, it's interesting to know how successful the establishment of the crops was, and how many plants essentially you have in the field that will produce the yield. So to count all these plants, we will create a detection, and with the PlantAI tool, you can create multiple detections in the same field in cases when you want to do something else than count the plants. So for example, here we could create one detection to count the plants, but then use the same tool and the same workflow that I'm about to show to teach the tool to, instead of plants, identify, for example, these patches or weeds and create a prescription file for spot spraying application. But let's start with the counts and create a new detection over here. And in the first step, we will choose what kind of detection we want to create. So there are three different options. There are basic counts, which is suitable for cases like ours, where we just want to count the plants as accurately as possible. There is second option for counts with plant level data. So that's for cases where we not only want to count the plants, but also, for example, estimate the size of the plants. And the third option is weed detection. So the workflow is roughly similar for all these three cases, but there are small subtle differences that I'm going to show in a few seconds. So let's create a detection of this type, basic counts, and click continue. So in the first step, we need to provide a few examples of what the plants that we are looking to identify look like. And to do that, we will use this bounding box tool to outline three plants. And then after that, the tool will provide here a box within which we need to outline all the other plants. And all the data within this box will be then used to train the tool to focus specifically on this type of plants. And it will actually create both positive and negative examples. So everything that is not outlined with boxes will also be used to train the AI, but as something that should be ignored. So it can be a good idea to place this box such that it includes both the plants that we want to identify, but also stuff like weeds, for example, that the tool might identify mistakenly. And by including them in this box, we can teach the tool to ignore them. So now that we've placed this box on a specific part of the field, the only thing we need to do is to go ahead and just outline all the plants, which I'm going to do right now. Okay, now we've got the first set of examples ready, and again, super important to outline all of these plants. The next thing that we're going to do, we're going to click continue. And in the next step, we get this small test area where we can quickly test the tool and see how well it works with the examples that we've provided. So we'll just place it somewhere over here on the field and click run test detection. And what's happening now behind the scenes is that our general agricultural AI model that we've trained on a lot of different crops will be fine-tuned, so customized for this specific use case, and ideally would yield perfect results from the beginning. This is a process that can take a couple of minutes, so while this one is processing, we will switch over to another data set and see how the counts with plant level data work. So over here we have another field, this time with pumpkins. And as a pumpkin grower, right before the harvest, it's really interesting to know how many pumpkins you have to make an yield estimate, but also to estimate the size of each pumpkins, because there are quite strict categories of pumpkins of different sizes and pricing for them varies. So we will use the almost exactly same workflow as in the first step, but this time we will, apart from just counting pumpkins, will generate plant level data like diameter, area, and length of and width of each pumpkin. So we'll create a new detection here, and this time choose this second option, counts with plant level data. Click continue, and in this step we need to also first create 3 examples of the pumpkins that we are looking to identify. But this time, instead of a rough bounding box tool that we used previously, we will use more accurate tools to extract the shape of each pumpkin accurately. So for pumpkins that are of a round shape, we can use the circle tool. So we just place a point here and then drag it until the edges. Maybe we can also annotate a tool like this. And then if the pumpkins are of non-round shape, we can use another tool here, freehand polygon. And with it, we can draw almost any shape easily like with a pen. And when we want to estimate the size as accurately as possible, we also want these examples to be as accurate as possible. So we want them to accurately outline the shape of each individual pumpkin. So most of the pumpkins here are quite round, so we can just go ahead and outline all the pumpkins within this box. And again, here it's also super important that we outline not just some of the pumpkins, but all of them, because all the data within this box that is not outlined will also be used to train the PlantAI tool, but is something that should be ignored. Okay, now the first set of examples is ready here, and similar to how we did in the Cabbage case, we click continue. We get this small test area that we can do a quick test on and just kick off the detection. Okay, now after a little while, the model is now trained on the examples we provided, and we can see how the detections start popping up. So the detection itself went pretty quickly, and you can see that it identified almost all of the plants, so it looks pretty good. We'll give it just a few more seconds to finalize the results and see what it looks like. All right, now the results are in and we can review them. It looks quite accurate to me. There are some plants that were missed, but in the next steps we will have a chance to improve this accuracy by providing more examples. So in this case, we just ran a small test detection in a small area, and that doesn't cost anything. So you can try this free of charge, and you can even do another iteration and go back and provide more examples and rerun and then see if the model improves. But here we can see that it already performs pretty well. So we will just click continue with the whole field. The field boundaries that we've created beforehand are already applied. And we will just we'll get this estimate of what it will cost us to process this whole field. So it's based on the area. And we will just kick off the detection, and the process will essentially repeat. Now the model will not be trained again because we haven't changed our examples. So then it will start detecting the plants in the field right away, and the detections will in a few moments start popping up here as well. So the first results are in. We can see how it detects the plant quite nicely. We can also see that the tool detects some weeds, so that's something that we will need to deal with a bit later. But now let the tool just do its work and detect the plants in the whole field. Back to our data set with pumpkins, we can see that the results are now in as well. The only difference here is that instead of boxes, the tool detected pumpkins more accurately, so it detected the shape of each pumpkin, which is what we need. So now we can, similar to the first example, proceed to processing the whole field. So again, the boundaries of the field are applied automatically. But the difference here is that we get to choose what kind of plant level data we can generate here in addition to the plant counts. And in this case, with pumpkins, we are interested in size metrics. So we will check for diameter, area, and maybe length and width, so that we can do the size estimates in pumpkins that are not strictly round. There are also other options, so height can be useful in cases when we want to, for example, count and estimate size of the Christmas trees, There are plant health metrics as well, so that's maybe useful for different types of salads where we want to estimate number of plants affected by some sort of disease. So all those options available here under the plant level data. And similar to the previous case, we get here a breakdown of what it will cost us to process based on the area that we select. And we will just kick off the detection here and now process the whole data set. And then we will be able to review the results and see if we need to improve something or not. Now the whole cabbage field is processed, and we can review the results and then decide if we want to do another iteration and add more example and refine them, or if we are happy with the results and can proceed as it is. So first of all, the first thing that I noticed here that, as we already seen while the detection was in the progress, that there are quite a few of weeds here detected as plants. We can also see inside each box there is a number, which is something that we call confidence score. So that's a prediction that AI makes on how likely something that it detects is to be what we want to identify. So you can see that most of these weeds actually have lower score than the plants. So all the plants are around 0.99, while the weeds have lower. And we can easily get rid of them by simply dragging this confidence score slider a bit higher. And we can see as we move it to the right, many of the weeds with lower score are removed. We need to be cautious so that we don't remove any plants that we actually do want to identify. But somewhere around like 0.9 is a reasonable threshold to put. We can also here review if there are any plants that the tool missed. So most of it looks pretty good. Here we can see an area with mostly smaller plants that the tool actually does miss. So that's something that we can also improve. And to do that, we will first just put a note into this area as something that needs to be improved, so that we can then easier find this spot later on and revisit it and see if in the next iteration the tool actually did a better job here. So let's put a note here and then put another note here when we have a lot of weeds. And then maybe we can move over to the other part of the feed and see. So here the plants look a bit different. It looks like the images were oversaturated in this case, so it turned out much more brighter than in the rest of the field. So something that we also need to teach now the AI to detect. So let's proceed with these three areas that need improvement. So what we will do next is we'll click on this option, provide more examples, and then add another example box in those areas that need improvement. So now we want to essentially repeat the process and draw the boxes around all the plants within this area. But because the tool already has detected some of them, we can actually select the box and just load these detected plants and then only outline the missing ones. So it's still going to be quite a few plants here because most of the plants in this specific area were missed. So we will just do that real quick. All right, now this small area is completed. Then let's go over here and add an example box here. So we'll just click Add Examples and place the box somewhere here so that it includes some of the plants. We don't want to, although we don't want to have a completely empty boxes. So the best example is where you have both positive and negative examples. Then we will do the same thing here. So we will load the boxes from the detection so that we don't have to draw these boxes around the plants. But what we'll need to do here is to remove all the boxes around the weeds that were detected mistakenly. So we will just select them. Holding the Shift button click, we can select multiple at the same time and then just click delete. So now these boxes are deleted from this example, and this example will now should technically teach the tool to ignore everything that looks similar to this. And then we had another area over here where quite a few plants were also missed. So we will add a fourth example area and then do the same thing here, load the existing ones and then outline all the plants that were missed. All right, now this example is also ready. Now we have 4 examples that the AI will be further trained on, so we should technically get much better results. So we'll just click continue, and then here nothing else to choose. We just run the detection again, and now the model will be trained because we have added more examples. And then once again, it will process the whole field, and we will review how the results turned out. Now, while the second iteration of the Cabbage field is now processing, we can have a look at the results of the pumpkin dataset. So now the whole field has been processed here as well. And we can zoom in and have a look at the results. And it looks quite nicely here. We can see that pretty much all the pumpkins have been identified. There are some false positives like this here and there. So something else detected as pumpkin, although it's not. And we can either add another set of examples in this area and teach the tool to ignore stuff like this, or we can just set the threshold higher and make this false positive with lower confidence score disappear. So at this point, we can choose now to either do another iteration and add more examples and refine the results like we did in the case with Cabbage. Or we can say that we are happy with the results and want to proceed with the analysis. In that case, we would click this button over here. And after a few moments, we will be able to analyze this data even further, and we'll be able to categorize all pumpkins by size over here in the plant counts tool. So if we toggle this tool, we can see that it automatically created 3 classes for us. If we want, we can add another class here. But let's say we want to classify all pumpkins in small, medium, and large size. And then we would just need to set the thresholds here for what is a definition of a small pumpkin. So let's say it's pumpkins under 15 centimeters in diameter. And then what is what is a medium size? So let's say it's everything between 15 and 25, and then the large pumpkins would be anything above 25 centimeters. So as we do these changes over here, the tool automatically calculates how many pumpkins we have in each of these classes, and the visualization is also updated in the map. So we can see that the majority of these pumpkins here is in this middle range size class. And we get this breakdown both percentage-wise and by the number of the pumpkins. So that's pretty much it when it comes to this type of analysis. We can then, under the export type here, download also the results if you want to generate a PDF report, or if we want to get access to the raw data, we can choose this option over here, and then we will get a shapefile with georeference polygons identifying each pumpkin. Now let's head over back to our Cabbage dataset, for which the second iteration has now also been processed, and we can review the results. So we've marked these 3 different spots where we saw that the improvements are needed. Now we can zoom into those and see what it looks like. So it looks like the plants that previously were missed over here and now get identified. There are still some misses over here and some sort of weird detections where a group of plants were detected as a single blob. So we'll probably need to make further improvements here on the edges of the field. Then let's go back over to this one. So here we had quite a few plants missing after the first iteration, and now it looks like the tool identifies them pretty well. And over here we had quite a lot of detections on the weeds. So that's the blue rectangles over here, results of the first detection. And we can see that now those are not detected anymore. Same here, it looks like still some weeds are detected, so this probably needs also an improvement. So we would want to provide more examples in this area and run another iteration and see how the results improve. But let's say that similar to pumpkins, we are happy with the results as they are, so we will probably move just this threshold over to somewhere above 0.9 and then click Proceed to Analysis. And in a few moments, this dataset will be published, as we call it, as well, and the results will be saved and will be available for access at any time in the future. So because we have chosen the basic counts, so we didn't calculate any plant level data, this plant counts tool over here shows a bit more basic data. So we just see the total number of plants in the whole field, and then we also get the average for average density of the plants across the field. We could also use, for example, tools like zonal statistics if we want to get these numbers for any specific zones in the field and do more detailed analysis. And similar to the pumpkin example, we can head over to the export and generate PDF reports or download the raw plant counts data. All right, that's it for now. I hope you enjoyed this video. If you have any data where you can test the plant counts, feel free to give it a try and let us know what you think. See you next time.